Tonight we're going to be talking about auto-analyzing Ruby code for fun and quality. My name is Dave Raffensperger and I work for Crew. So why would you want to auto-analyze Ruby code? There's a number of reasons. You might want to enforce a style guide. There's a gem for that, the Rubocop gem. You might want to catch security issues in your app like SQL injection or unexpected calls to send and so on that could be a security risk. There's a brakeman gem that will go through your app and search for that. And similarly, there are gems to do things like checking for code smells or giving yourself code metrics. And then there's services like Code Climate that wrap a number of these gems together. And I really do recommend these types of code analysis gems, perhaps using a service like Code Climate or using the gems directly. But tonight, the focus of my talk is going to be on using Ruby analysis to catch things that are the result of dynamic typing gone wrong. Basically things like undefined methods at runtime, stuff like that. There is actually a gem called RubyLint which attempts to do this. It statically analyzes your Ruby code and basically does some type inference and sort of actually simulating your code in a limited way to infer types. But a major downside of it is it doesn't take into account dynamically defined methods. It requires some setup for gems that define methods, and your own dynamically defined message it just won't see. And that leads us to this situation that Ruby code analysis is actually pretty hard. Ruby's awesomely dynamic. It's great for rapid development. I really enjoy it, and that ability to just have dynamic types, to create methods at runtime, to do all kinds of cool stuff is a lot of fun, and it can be very productive. But the implication is that just statically analyzing code without running it, basically it's impossible to tell whether the code's going to call an undefined method or not. And you probably already figured out this little example here that if you had an ideal Ruby static analyzer, you could just basically fool it. You could ask it, am I going to call an undefined method? And then just do the opposite, whatever it tells you. Define the method if it thinks you're going to call an undefined method. If it thinks you won't, then don't define it. So that's the big caveat with this, is that especially if you're using something like method missing, whether or not your code calls an undefined method is an attribute of your entire state of your code and your program at that point. So checking for undefined methods is going to be limited. But with that in mind, fewer of these would be nice. These are real-world production errors that have come across my email box. Undefined names, undefined methods. You can be laughing at this, that's fine. How do these happen? Each one has their own story, some kind of carelessness, maybe some, we didn't have enough specs, somebody was pushing it out, whatever. But it happens. And so really integration tests are the surest way to quality check your Ruby code because you're running it in as a realistic environment as possible. You're basically saying, all right, let's actually run this code and see what happens. And that's what an integration test is doing automatically for you. But integration tests have a cost to write. That's extra time. It also has a cost to run. Sometimes they can be slow, they can be brittle. So what can code analysis do for us? Well, code analysis can do two things for us. One is it can make our unit tests smarter. We're going to see how to do that. And the second thing is it can provide some limited safety even in the absence of tests. So I want to talk a little bit about the Ruby code analysis toolbox. So there's three key pieces to Ruby code analysis that I'm going to use tonight in the examples. And the first one is reflection, and that's just basically when your Ruby code is loaded, when it's running, you can inspect things like attributes of a defined method on a particular class at a given time in your app. Then there's the parser gem, and that's what actually takes in Ruby code and converts it to what's called an abstract syntax tree, which is a fancy term, but it just basically means a representation of your code that you can easily manipulate. And then the third one is Ruby's tracepoint API, and that lets you actually trace Ruby virtual machine events like calls, returns, exceptions, and so on. And interesting, the parser gem is what powers Rubocop, powers Brakeman as well, and a number of other static analysis gems using either the actual parser gem or a similar gem. And then Ruby's tracepoint API powers bybug. So if you ever step through Ruby code with bybug, you're using tracepoint indirectly. So I want to demo these three pieces of the toolbox to you. So I'll jump over here. So here's just a really simple Ruby class person. And what we're going to do is we're going to just bring up Ruby console and load that code in. And then we can do that here. We can say person.instance method say hi. What's interesting here is that this say hi method was actually defined over here on line 6 with define method. So it was defined at the time when the code was loaded in, and it wasn't a regular method definition. And similarly, we can get some things like the parameters. So there's one required parameter, friend, which corresponds to the block there. And we could do other things like if we just want to check whether a method's defined, there's this method defined method that here we can check for the intro method, see whether that's defined. If we try something else, it's going to say it's not defined. And there's other things you can do. You can look up a constant in the system. There's a variety of other ways you can inspect the loaded Ruby code that you have at a given point. And I'm calling that reflection. So that's the first piece of the toolbox. The second piece of the toolbox is this actual parser gem. And the parser gem brings in an executable called Ruby parse. And it takes a Ruby file and it prints out what's called that abstract syntax tree. So if you've used a language like Lisp or Clojure, it's going to look really familiar to you. And if you're just familiar with Ruby, it could look new, but it's pretty simple. It's just a series of nested parentheses that represents the structure of your code. So you can see the highest level, there's class, and then you can think of the next things as arguments to the class. There's a const person, and then nil. Nil is what the class inherits from. So if it doesn't have anything it's inheriting from, it just leaves it nil by default. And then there's the method definition, its arguments, and then the body, which is a send. And we can actually interact with this programmatically as well. So bring up a console here. We can require the parser, load in the Ruby source code here, and then there's this method parse we can call. So we see this same tree, but now it's actually a Ruby object we can play with. So you can get the type of it. The type is a class, and then you can get its children. And you can see you get an array of the children of that particular node in the abstract syntax tree. And it's a recursive object. So you could take the third child and get its type. It's a def, because that's the method definition there. And you can see its children. So that gives you an idea that this is how those static analysis gems work. They parse the code into this abstract syntax tree, and then they can do whatever iteration on it, whatever searches in it. Because basically then you're searching Ruby code as a Ruby object, which is pretty cool. So that's the second one, this parser gem. And the third one is tracepoint. So to do tracepoint, it's built into Ruby, so there's nothing you have to require, no gem you have to pull in. And you can just say tracepoint.trace and then give it the virtual machine event you want to trace. So here is starting tracing a line, and then what you can do is you pass it a block, and when that event occurs in the Ruby virtual machine, it's going to call your block and give it an argument. And that argument has a number of attributes that give you information about that event. So like you can get the line number, and then for the method call event, you can get the defined class and method ID. Then you can also get the local variables that are in the binding at the time when the Ruby method is called. And this is not part of tracepoint, but you can also get the call stack of the method at that point. And then similarly, there's a trace for return, and it has a return value. And then C calls and C returns, so methods that are defined in C, either in the Ruby core library or in a gem you bring in. There's a similar C call, a C returned event you can trace. And there's a few others that you can look up on your own. Exceptions and thread changes, beginning ends of classes, and a couple others. So then here's just some really simple code to demo this. So if I run ruby trace.rb here, it'll basically print some output here. So we start tracing lines, and then we get to line 5, line 17, line 22, and by the time we get to line 28, we started tracing C calls. So we see that it actually has a C call for trace. And then when we get to line 34, there's this C call for method added, and another C call for method added. And then at line 44, it starts to get a little more interesting. You can see it's saying say hi is called, and it prints out the argument friend, shows you a call stack. Then the next speak is called. And then here it actually does the call to puts, this nested series of C calls. It prints out hi Joe, and then everything kind of returns out. So that's another sort of cool way you can inspect what's going on in Ruby with tracepoint. And This is not directly related to static analysis, but we're going to see how this ties in as we go. So that's the Ruby code analysis toolbox that we're going to use tonight. And how are we going to apply this? Well, we're going to apply this in 3 ways to try to catch some undefined methods. Bearing in that big caveat that we talked about, how could we catch at least some undefined methods with these tools? So we're going to combine these 3 tools to do 3 things. One is help our unit tests catch more bad method calls in between classes, try to catch undefined instance methods without tests, and then the third one is to catch bad calls on arguments, method arguments via sample types. And I'll talk a little bit more about that as we get to it. So I want to demo, though, this first one about enhancing unit tests. So let me move to this next point here. So here's just 2 simple classes. I'm calling it a greeting app and a greeting. And if you look really carefully at this, you're going to notice a couple things are wrong. Maybe more than a couple. A number of things are wrong here. So one of the things that's wrong is we're calling this method say hi. But in the greeter, it's actually not called say hi. It's called greet. And we can see that if we ran this, we get this error. Undefined method say hi for struct greeter. Okay, that's not, in this case, it's pretty obvious. But it would be nice if our specs could catch that and give us that warning as we're developing their code. Depending on how you create the specs, they might be able to, they might not be able to. So here's a case where they won't be able to. So I'm going to run some specs for this, and all the specs pass, which is, in this case, a little discouraging. And it actually also has 100% coverage. If you look down here, coverage report generated, 9 lines covered. And what's going on here? Well, what's going on is that we have 2 unit tests, and the unit tests basically just reflect the code. And so here we're creating a RSpec double. If you're not familiar with RSpec mocks and RSpec doubles, basically this is just an imaginary object that says, I just want an imaginary object that will respond to the say hi method and just return nil. And so what we're doing is we're creating that imaginary object, and we're saying pretend that the greeter new gives us this imaginary double object, and then we're going to run our app and expect that say hi got called. And similarly down here, we're going to actually call the correct method greet. And so both unit tests pass, but there's an incoherence in both the code and the unit tests. And you might think this never happens. Well, maybe it's not going to happen the first time you write the app, but maybe you go and you refactor one class, and you forget that you use it somewhere else, but that class test passes. So you're like, all right, we're golden. You deploy or whatever, and something breaks. So what can we do? So it turns out that RSpec mocks actually provides another feature, which is called a verifying double. And all we do is we just change this very slightly. We say, call this an instance double instead of just a regular double, and we pass in the class. So it's saying, this is an imaginary object, but it has to be, it is of type greeter, and so the only methods you're allowed to stub on this are methods that greeter would implement. So you can see this error message here, greeter class does not implement the instance method say hi. All right, so that's great. That's already an improvement, and what it's doing is it's actually using reflection, the first toolbox we talked about, and it's just saying, okay, pulls up this class and says, does it have this method defined on it or not? And if it doesn't, it's going to give you this error message. So let's go ahead and fix that. Let's change this to greet and run that spec again. Oop. Okay, I see what happened. We had to change the spec as well. All right, so great. The test passes. But we actually have a second problem with this code. So I'm going to run it again. And this time, the problem is a little more subtle. It says, undefined method toSim for nil class. So what's going on here? Well, what's going on here is we have another communication problem, maybe a breakdown between 2 teammates, maybe yourself, you forgot what's going on, whatever. So up here we think we're going to use nil for the default language, all right? And down here, we're actually saying language has to be a string or a symbol. And so we're coercing language to a symbol. So what happens when we pass nil is the code's going to blow up. It's going to say, all right, there's no method toSim on nil because you're supposed to pass a string or a symbol and you pass in nil. Wouldn't it be nice if we could actually do something about this, make our double just a little bit smarter? And so that's what I've done with static analysis here. Is there's this gem type tracer which encapsulates the examples that I'm going to talk about tonight. If you want to see lot of the details. You can look at the code for that. But basically, it's going to patch this instance double to be just a little bit smarter. So if I run this again, it actually gives me a new message. It says, called stub method greet with unrealistic language argument nil. It should respond to toSim, but it does not. So what this is doing is it's actually going in there and it's parsing the method that's being stubbed. And it's saying, okay, well, based on that abstract syntax tree, what method calls would this method be making on its arguments? And then do these arguments respond to those methods? And then let's actually fix our code to kind of demo how this has to, some caveats this has to work. So let's say we made the default language German, rerun the spec, and it's going to pass. So basically that checking, one of the things it checks for is if you assign the argument something else, well, you're implicitly changing the type of the argument. Like before it was a nil, now it's a symbol because you assigned it to a symbol. So basically if it sees an assignment to that argument, it's just like, all right, I can't analyze this method anymore. I'm just going to say that it passes. Similarly, if we did something like this, return unless language, it's also going to be okay. But if we don't have anything like that, no branches and no assignments to the variables, it's going to come back and complain with static analysis. So that's the first example, which is this smarter RSpec verifying doubles. And basically, just what we've seen, you can have 100% test coverage, still get failing specs. And if you just take one thing away, I would just encourage you to consider using instance double in your code, and where that's going to be appropriate to just give your unit tests a little more realism and a little more security. So static analysis, though, can make that instance double just a little bit smarter. So what if, though, we don't have any specs? For one reason or another, maybe we're inheriting a project for somebody else. Maybe we just didn't believe in specs. But, that's a debate on its own. But for whatever reason, let's say we don't have tests. And let's say we have just a simple Rails app. So I'm going to show you guys just a kind of a silly little Rails app that we're going to use to demo this. So this quotes app. So there's a few famous quotes here. Genius is 1% inspiration, 99% perspiration. And then we've got this random combination. So it just splices two quotes together. You get some kind of silly quotes. Some of them make sense, some of them don't. But whatever, you get the idea of this app. It's just a very simple app, just a couple models. And so let's say, one of these models is a quote model. And what's interesting about ActiveRecord models, if you use them at all, is that almost all of the methods that are interesting in an ActiveRecord model are defined dynamically. So all of your attribute methods, they're not only defined when you load your code, they actually aren't defined when you load your code. They're actually defined the first time you do something with that model. Like you create a new instance of it, it's actually going to query your database to figure out, like analyze your tables a little bit to figure out what fields you have in your tables, and then it's going to find the methods on the class for those fields. And even the fields that are not defined that dynamically, so something like belongs to user, this user method down here that I'm calling, it's defined when the class is loaded. This belongs to actually, deep within Rails, it's defining that method, user. So this is where just purely static analysis is going to break down, because it actually involves the state of your database as far as whether or not these things are going to make method calls. But what we can actually do is build a Rake task that runs in your app's environment. So it loads up your whole app and all of the classes in your app, and then it's going to do static analysis in the context of your own loaded code. So let me just run this Rake test. Let's say, in this case, let's just put a typo here, and then I'm going to run Rake check method tracer Rake tracer check method calls. So I'm going to run this Rake task on the app, and it gives back this message, likely undefined method, text ASDF for quote instance, and it gives a line here, line 5. And then if I delete this, rerun it, it'll rerun and it gives no output. So, and similarly I could do something like created at, that's another, create at, created at, it's going to be fine with that because that's another attribute method that is actually dynamically defined on this class. So in order for this to work properly, it also takes some initialization. So this is the initializer of this type tracer gem. And one of the things it defines is this attribute method definer. And so this is run midway through the analysis. So the first part of the analysis, it loads all your code. The second part of the analysis, it calls this method. And what this method is doing, it's just going through every ActiveRecord model and it's calling new on it. So that's querying your database, defining all those attribute methods, and then it can do the parsing of your code and checking for undefined methods. So that's basically the second approach we could take, which is just running a script to check for undefined methods. And it's only going to check for top-level methods, so like text here, but not split. So it's only checking it direct methods that are called on self, essentially. So let's jump back to the presentation. So that's the second way we could do code analysis. We rake out bad method calls. So again, a lot of methods get defined at runtime, and this type of rake task is something you could just bolt onto your CI build that check to see if there's any undefined methods. That's just another potential piece you could use. So what about, though, things that are not a top-level call? So like text here, it's being called on an instance of quote because it's within quote. It's being called on self, basically. But this split call here, what type it's being called on depends on what type text is, and that gets into the whole like type inference thing throughout your code. So let's look at another model. So this random combiner, this is where that actual combination of quotes happens. So let's say we've got this site deployed and it's kind of successful. Like people are entertained, they're having fun, but our boss comes in and says, look, you know, this is fun, all fun and games, this is great, but there's just so many Dilbert quotes out there. We're getting overwhelmed with Dilbert quotes. Can you just go in there and just do a quick fix, just filter out all the Dilbert quotes until we get this thing figured out? So I'm like, all right, I'll do that. So let's do this. Where not author Dilbert. And save that, and then let's go and let's go run the app. So, okay, undefined method where for array. So what happened there? Well, let's look at where this is called. So it actually turns out, for better or worse, the person who wrote the controller wrote a little caching function, and so it's actually caching all the quotes and it's converting it to an array. So at that point, I was pretending like it was an ActiveRecord relation. I was like, I'm going to call where on this thing. Turns out it's an array. So in this case, it's a really simple example, right? We just refresh the page. We see that there's an error. We probably would have caught this. But imagine this was buried deeper in your code somewhere. Maybe your test coverage is not that great. Maybe you thought you tested it and it looked good. Maybe there was an edge case you missed. Wouldn't it be nice if we had a way to basically do some checking in this case as well? So here's what we actually can do. There's another rake task we can run. Oops. Check type tracer. Check args sends. And so this is going to do something that involves the type sampling. So the line down here at prints is it's saying it's using sampled types from this Heroku app. And I'll get to that in a second. So this app is also deployed to Heroku. And in this running app, we're going to make the assumption that what we've deployed, it's not going to be perfect, but at least it's been somehow vetted. You know, it's deployed, it's running, there's real users hitting it, and there's an endpoint here called sample types. And what this sample type, let me make this a little bigger. So remember we saw the type of the trace point API. So you can actually trace into Ruby virtual machine events and generate a representation of what the dynamic types are for methods, the type signatures. And so here's a git commit that represents the git commit of the code that's been deployed to Heroku. And then here's this types info. So there's a quotes controller, various things here. If we scroll down, here's the random combiner. So this random combiner class has this method combine two quotes. And that was the method we were just modifying. And it takes in, as far as arguments, it has one required argument, which is the quotes argument. And then it has argument types. So as it was sampling these types, what it saw for quotes was an array. And what was called on that array was flat map. So the idea here is that although this particular example I'm not using it, I tracked what was called on it to kind of capture the idea of duck typing, that you might pass a variety of things into a method and maybe it calls the same method on everything you pass in. And then here we track the callers of this. So it was called in this random combinations controller. So that production, well, I call it production, that at least deployed app type sampling allows the static analysis to kind of be fed some information about what type this quotes argument could be. And actually, it could be multiple types because you can pass several different things to a Ruby method. It doesn't have to be strictly type. But if the Ruby method doesn't have any branches in it and it doesn't reassign that type at all, then everything that you pass in is going to get called on whatever calls you make on it. So if even one of those types is a problem, your method has a problem. So this error that it gave, the method combined to quotes as type sampled may receive a value of type array if the argument quotes. However, that type doesn't contain the instance method where, and it shows this location. So what happens though if we actually go in and we change this? So this may not be the best way to change it, but let's just say, all right, the boss is in a hurry. We really care about these Dilbert quotes getting out of there. The caching was just a random idea. That doesn't really seem to be helping us. Let's just do quote.all. So we're going to make it an ActiveRecord relation again. And then we can rerun the app. It works now. And similarly, the Rake task should now, it just comes back with no errors. And how did it do that? The way it did that is based on the git commit. So essentially what it's saying is it does a git diff and it says, if you changed all the places that call this method, then realistically, you could have changed what you're passing into that method. And you may have changed the types of those arguments. So essentially, the analysis says, all right, I don't know anymore. I'm not going to report that as an error to you. So that's the kind of this third approach, which is using sample types. So basically, as I've talked about, the implicit method signatures in a Ruby app, they're implicit. They often are there, but we don't specify them in Ruby. And the git diff is needed to kind of invalidate those based on what the callers are. And then that enables us to do this check for local changes on a method. And you can imagine other possible uses for sample types. Like one might be using these sample types and feeding it into something that can do more complicated type inference and analysis of your code. So right now I just handled the single example where you're making a method call on an argument to a method. But you could imagine kind of feeding the type inference through. And it's sort of like that Ruby lint gem that I mentioned that does some cool analysis of your code but doesn't take into account dynamic typing. This would be an idea potentially to combine those two. Another application might be, let's say you have a really big test suite, it's great, but everything's doubles. It's not instance doubles, and you want to just say, what if I could just auto-convert all my doubles to instance doubles? If you could do type sampling in a deployed app, or even in your local machine, click through it with the type sampling, then you could presumably go through and have a script that would replace that. And the third one might be generating yard docs. Yard docs, if you haven't heard of those, is basically sort of like Ruby's equivalent to Java docs. If you use Java docs, it's sort of like documentation about a method and the types. I don't really use it, but you could imagine if you're running a library, you want a lot of people to look at it. You didn't have those, you wanted to generate them, you could imagine doing that. And then the last point is that there is an overhead to this trace point stuff. And you could imagine in a production app, only sampling a fraction of requests could be enough to still give you realistic type information for your analysis. But as a caveat, I've not actually done this in an app deployed to real users yet. But that's an idea of how you could basically make an approach like that feasible, is by sampling only a fraction of requests. So, yeah, I was just going to switch into questions. Yeah, definitely.
So two slides ago, we were saying we're using the Rake task, and it was mentioning, oh, this is an array, and you're passing in, and I expected a calculation, and then you fixed it, and then it passed. But you said it's not that you fixed it, it's that it's looked at the changes from the git commit and said, oh, I just don't know because you changed stuff.
Right.
So it's not testing it's only looking at your actual code against the commit to say,
Yeah, let me demonstrate that to you. So here, remember how I changed this? Before it was cache quotes, and so here, if I run this, it's gonna complain, right? But let's just say I just did some random change like this. Okay. All right, it doesn't complain, and this is exactly your question. Okay, and this is basically a proof of concept. Like I actually imagine if you thought this is a really cool idea and you were like, okay, we're gonna build this for real, we're gonna build our startup, whatever, then you could imagine using a little more fine-grained information in that git diff and say, all right, well, I know the line that it was called from. Did you change that line? So this would be better, like because here I just changed a random line, right? But if you change that line, so that'd be an improvement.
You could also just make a commit now, and then if you reran it, it would see it.
Well, it does a git diff on the file. So it looks at the caller. So going back to, let me pull back up this sample type. So okay, so this caller, it has the name of the file, which is the random combinations controller. So it knows that this method combined two quotes is called by this file. So in version 1, this proof of concept, it just says, did you change this file at all? And if so, then all bets are off for this simple analysis because you might have changed the thing that calls it. And actually, it's a little more subtle. It says if all the callers were changed. So you might have called it another file as well. And if that file returned it an array, and you just changed one to an ActiveRecord relation, it's still going to warn you. It says, hey, we've got this other thing calling it over here that sends it an array. You're fine with this caller, but not fine with this caller. But like if you renamed the file, that would be a similar thing. And if you just created a new commit, that wouldn't necessarily do it. Like if you change a random file uncommitted, it just does the diff between the commit that's here, the deployed app commit, and your local changes. Not even the head commit, just whatever you changed locally. So yeah, it's just seeing if that file's changed.
So how would you generate this file on your new commit? You added that change that didn't fix it, but it stopped the analysis from it. And now you want to say, okay, this is the new head. You need to generate this again, and now.
Right. Okay. Let's do that. So let me go back to quote.all, right? Because that was where I changed an ActiveRecord relation. And let's actually commit this. Let's say exclude Dilbert, right? And then I'm going to push this to Heroku. And so yeah, we'll just let it go, let it do its thing.
I guess you have to deploy it, or it cares about what's deployed, not what's committed.
That's right, exactly. And the idea is that, and this is the idea behind it, is that what's in production is sort of like stable in some way. I mean, we know production breaks, right? But stable, right? So the idea is that you've got this thing deployed to real users who are banging on it, and more or less it's okay. If it's not, we're emergency mode, right? We're all hands on deck fixing it. So if you're just changing something locally, then comparing it to production is a decent thing to do. So yeah, to answer your question, so after we refresh this, now sample types is empty. We just redeployed the app. But if we go to do a quote random combination and then go back to sample types, so here now it's actually an ActiveRecord relation. And the method that's called on it is where. So yeah, that kind of gets, does that answer your question, I guess?
Yeah, no, I think those things.
Yeah, so it's what's deployed. I mean, you could imagine, you could do stuff like you could run your, you could imagine like making another directory on your computer. And let me actually just show you this. Okay, so this is where it's configured. So this is the type tracer initializer, and down here we have the type check root path, which is Rails root. What are we type checking? You know, regular expression. And this is an important one, the sample types URL. So that's where it's going to pull it from. And then this is the git commit that's basically feeding that git commit that's being served. So like what you could do is you could have another directory on your same computer, fix it to a particular commit, run a Rails server there, and maybe on a particular port, and then aim this URL at your local machine. And that would be a way to compare it to a commit. The idea I had was just basically users are hitting your app all the time in production, so you're kind of outsourcing this type tracing to them, and sampling a small fraction, you're generating these types, pulling it down, comparing. That's the idea anyway. Yeah.
Are there any kind of authentication config settings for that?
Yeah, that's a good question as well. So
As much as I want to give people access to every call.
yeah. So what I have in the routes right now is, for a simple demo, I just have this sample types thing. A simple thing you could do, this would be really easy, just create an environment variable, a random secret, and make your route be this long URL with a random secret in it. And so your app then, nobody knows that secret, they don't know where to go. You could bolt on some authentication, like you could then basically what I would have to do is modify the library to support that authentication, however it worked. But in principle, it's not hard to do. But yeah, for simplicity, I left that out. But I thought about that too, because admin points, it's vulnerabilities, that's important for sure.
Just knowing what every controller thinks for meta types would be a very interesting security vulnerability.
Yeah, sure. So, yeah, any other questions or?
What's the impact on the performance of your app?
Yeah, so in this particular app, it's so simple that it's kind of hard to notice something. But I think in a real production app you would notice something. There's actually a gem called RB trace, and that gem is designed to be used in production. And it's like, if you want to figure out what's going on in production, you can use the RB trace gem, and it'll print out method calls, and you can see it's a debugging tool. And for that, what they've actually done is they've hooked into the Ruby virtual machine, but using C code. So all those Ruby events you can capture in C as well. And so if you had an idea like this, you're like, all right, this is a great idea, but you really need performance, you can tap into those events with C as well. But to answer your question, I don't really know. I haven't benchmarked it in a serious way, but it is important. And actually, one thing I did do is so there's this rack middleware that starts and stops the type sampler. And right now, I just have this condition here to be, if it's not test, sample it. But you can imagine something where, if there's a certain probability where you only sample like a very fraction of your requests. So 99.99% of users have no performance penalty, and a few users is like, oh, that took a randomly took a little longer, and then you're getting something value for your development process. So yeah, the short answer is I don't know, but I've thought about it a little bit. So yeah. All right, well, great. Thanks, everyone.